Am I audible?
Yes,
Yes, sir.
sir.
So I was discussing double slit diffraction. In case of double slit diffraction, you are having two slits. Size, they are identical slits. So here we are having two identical slits. We are having two identical slits whose width E is of the order of lambda so that diffraction should occur. Okay, so that diffraction should occur. So we should remember that in case of Young's double slit experiment, we were observing interference only. But here what we are saying, we are having two slits and we want to observe the double slit diffraction experiment. So in case of Young's double slit, we are having point sources or point slits. Okay, na very thin slits. In case of Young's double slit, you will have E less than this lambda. Why this condition was used in YDSC? So that diffraction can be avoided. So YDSC experiment is performed with very thin slits, point slits you can say, and this condition should be satisfied. When this condition is satisfied, so basically diffraction will not occur, only interference is going to happen. What happens in case of interference, if you are having a point slit like this, in case of point slit, you are going to have this type of wavefronts which will emerge from the slit. Okay? And at every point of this wavefront, because this is a point slit, okay, so at every point intensity will be same. Try to understand, at every point intensity will be a square here, a square here, a square here. But if you replace this slit, single slit, this point slit that is used in YDSC experiment by a slit, okay, na, whose size is of the order of lambda, then what will happen here? A lot of secondary point sources will emerge, and from all these secondary point sources, their individual wavefronts will start propagating in the forward direction. And as they overlap with each other, then in different directions, different intensity will emerge, and we call this as diffraction. So in case of diffraction at different angles, light which is traveling at different angles after diffraction from the slit, that will have different intensity. How that intensity varies with the angle, that is given by this formula. So in case of single slit diffraction experiment, I have derived this formula. So intensity was equal to a square sine square alpha upon alpha square. So it will be equal to intensity amplitude square. So what will be the amplitude of the light that is propagating at an angle theta? This will be a sine alpha upon alpha. This will be the amplitude of the light that is propagating at an angle theta with respect to the original direction after the diffraction taking place at individual slit. So this light, this part of the light that is traveling in this direction, what will be the amplitude? Amplitude will be a sine alpha upon alpha. And this alpha is a function of theta. So where this theta, this angle is emerging, ठीक है ना, that theta angle is emerging from here, from alpha. So alpha itself is a function of theta. Now similarly, light will emerge from this, light will pass through this second slit, this identical slit. So again light is going to be diffracted. So in different directions, intensity will be different. The light propagating in different direction will have different intensity. So again, I am going to choose the part of the light that is emerging from it and propagating at the same angle. Whatever angle I have chosen here, same angle I am going to choose here. So from both the slits, I'm considering that part of the light which is propagating at an angle theta after emerging from these two slits. After diffraction, when light is emerging, then from that light I'm considering that part of the light which is traveling parallel to each other. So in this way, this is theta. This is theta. Now these are, you can say these are two light waves which are traveling parallel to each other, or you can say ठीक है ना, where they are going to meet with each other, where they are going to overlap with each other at infinity. So if they are traveling parallel to each other, automatically they are going to overlap where? At infinity, at very large distances. Infinity means at very large distances. So we can sort out this problem. We are not going to the infinity or very large distances. This problem can be overcome if you place a convex lens here. So what will happen? This parallel light that is propagating after passing through the convex lens, ठीक है, they will overlap, they are going to focus at the same point in the focal plane. So where these two lights, they are going to focus, they will focus in the focal plane, they are going to overlap, they are going to superpose, and they will give some resultant intensity. So what I'm doing here, I'm placing a convex lens here in front of these two slits. So in front of these two slits, I'm placing convex lens here. So these are two slits. This is the original direction of the light, and I place a convex lens like this, very close to these two slits. So whatever light will emerge here, ठीक है ना, whatever light will emerge, that will pass through this lens, and where parallel beam of light are going to focus in the focal plane of this lens. So here I place a screen, where I am placing the screen in the focal plane of this lens. So this is the focal plane. So this is a screen which is placed in the focal plane of this lens. So what will happen if you are choosing two parallel beam of lights? ठीक है, from both the slits light is emerging, but I'm choosing only that part of light, ठीक है, that is traveling at equal angles. So here I choose the arbitrary angle theta. So this part, this angle is theta, this angle is theta. And after passing through this is symmetrical line I am drawing here. So after this, passing through this, they will focus at some focal point, focal plane, at some point in the focal plane. So they are going to focus like this. So what you have done, you choose two parallel lights, ठीक है, which are propagating parallel, emerging from two slits after diffraction, and they are propagating parallel. So here you place a convex lens, and by placing this convex lens, you forces, ठीक है ना, you are forcing these two parallel beams, ठीक है, or parallel lights to focus at the same point. So here they are going to interfere, ठीक है, what you are doing, you are superposing them, they are going to interfere at this point, and you will get the resultant intensity. So what is happening here? First, light is passing through individual slits, light is getting diffracted. So what is happening here? First, light is passing through, first light is passing through slits, through slits. And what happens? These slits, their size is of the order of lambda, so the light will get diffracted. So first, diffraction will take place. Diffraction takes place at individual slits, at individual slits, at individual slit diffraction will occur. Now what happens after diffraction? You are choosing parallel lights, ठीक है ना, part of the lights which are moving parallel to each other, ठीक है ना, part of the lights which are moving parallel to each other. So you are choosing that part of light, and you are with the help of this convex lens, you are focusing these parallel lights to a point here in the focal plane of the lens where you have placed the screen. Now they are superposing here, okay, they are superposing here, and because part difference between them is fixed. What will be the part difference? Try to understand here. Here part difference will be part difference between these two. So for this, I will draw a perpendicular from here to here. Okay, this parallel one. Okay. So this will be the part difference. This is not looking like this, but this will be the 90-degree here. Okay. So this will be the part difference. ठीक है ना? This will be the part difference here. So this part difference will be how much? So what I'm saying, try to understand this situation. This is one slit. Here I want to show you. This is one slit. This is opaque part. What you call it as? You call it as opaque part. And this is another slit. So they are slits. This is slit S1. This is slit S2. And this between part through which light cannot pass, this is called as opaque. Okay, this is called as opaque. These words they are going to use in numericals. This is opaque part. This is slit. This is slit. Width of the slit, I am assuming this is E. This width is E. And I'm assuming width of this opaque part, that is D. So I'm saying width of the opaque part is D and slit width is E. Now can anyone tell me what will be the center to center separation? Try to understand. I want to find out center to center separation between two slits. What will be the center to center separation? Try to understand. This is E by 2 here. E by 2 here. Half of this slit, if you are taking center to center separation, half of the slit is here, half of the slit is here. So this is E by 2 plus E by 2. So this is E. And width of the opaque space is D. So this separation, this will be E plus D. So slit to slit separation is E plus D. So slit to slit separation is E plus D. So if someone is saying separation between two slits, if someone is providing you separation between two slits, it means he is saying that E plus D. If he is providing you some value of separation between two slits, it means he is providing you the value of E plus D. ठीक है? If he will provide you the width of the slit, then it will be E. Slit width is equal to E. And if he says that width of the opaque part, then this will be D. Then width of the opaque part. Remember this terminology. Width of opaque space. Opaque space, a part, that is D. So many of the students think that separation between two slit is small d. No, that's not. If they are providing you the slit separation between two slit, it means they are providing you E plus D. ठीक है? If they are going to provide you the width of the opaque space, they will write that this is the width of the opaque space. So never confuse. Center to center separation is called as the separation between two slits. So if they are providing you separation between two slits, it means they are going to provide you E plus D. So don't confuse. This terminology should be very clear to you. So this is one thing. Okay? So you should be very clear here. So what is happening here? After diffraction, you choose two part of the lights. This is first part, this is second part. With the help of this lens, these two parts are focused here where they superpose, and part difference between these two parts is this part difference. It is equal to E plus D. It comes out to be E plus D sine theta. This will be E plus D sine theta. ठीक है ना? This will be. So try to understand why it will be. ठीक है ना? Because you are choosing this angle as theta. Try to understand this is theta. Why this is E plus D sine theta? First, center to center separation, this separation. So center to center separation, this is E plus D here. First, E plus D. Second, this angle is theta. So automatically from this line to this line, this angle is 90. This plus this is also 90. This plus this is 90. So automatically this angle is also theta. So what will be this? This is 90 degree here. This is hypotenuse. This is theta. So this part, this will be E plus D sine theta. This will be E plus D sine theta. You can look here. It is like this. It is 90 degree here. And this is hypotenuse. Hypotenuse is E plus D. This is theta. Theta. So this part will be how much? This will be E plus D sine theta. So in between these two parts of the light, this is first part, this is second part. Part difference is constant. You have achieved these two sources from the same light, so wavelength that will be same. ठीक है, frequency will be same, wavelength will be same because light is both the parts they are propagating in the air. ठीक है, here also light was passing through the air. Here medium is again air, so lambda will be same for both 1 and 2. Frequency will be same, and part difference E plus D sine theta, that will be a constant. So in between these two rays which are reaching here, frequency is same, wavelength is same, and part difference or phase difference, that is constant. So automatically between 1 and 2 here interference will take place. Interference is going to take place. So as a result of interference here, okay, as a result of interference, what will be the intensity at this point? This is central point. I assume this point is P. So what will be the intensity at this point P due to the interference of these two lights which are reaching at point P? What I was saying, what will be the amplitude of this light? That will be A sine alpha upon alpha. You can say this is A1 because you are aware what will be the resultant intensity. What will be the resultant intensity if two light waves, two coherent light waves are interfering with each other with amplitude A1 and A2 and with phase difference delta? That will be I will be A1 square plus A2 square plus twice A1 A2 cos delta. And if A1 is equal to A2, then it will become 4A square. 4A square cos square delta by 2. So I'm going to use that formula. So here, amplitude of this light is this one. And what will be the amplitude of this part of light? That will be same. That will also be A sine alpha upon alpha. And that is A2. And this A1 and A2 you can observe that is equal. So what will be the intensity after interference here that is taking place at P? P, that will be intensity at point P. What it will be? What is the formula of intensity due to interference? That is actually 4A square cos square delta by 2. Delta by 2. If amplitude of both the coherent light is equal, then this will be the formula. So what it will be here? That will be 4 will be as it is. What is the amplitude of both the lights? Here that will be A sine alpha upon alpha. This is the amplitude of both. A sine alpha upon alpha and whole square of this. And this is cos square delta by 2. Cos square delta by 2. Okay? So it will be equal to 4A square sine square alpha upon alpha square. And this is cos square delta by 2. Delta by 2. So what is delta here? If you look, delta is the phase difference. Phase difference delta will be 2 pi by lambda multiplied by part difference. Part difference is E plus D sine theta. So delta by 2, if you bring that here, delta by 2, that will be pi by lambda, and this will be E plus D sine theta. And I assume this delta by 2 as beta. I'm assuming it as beta. So what will be the intensity at point P, arbitrary point P? That will be 4a square sine square alpha upon alpha square, and this will be cos square beta. So what is happening here? At individual slit, diffraction is taking place first. When light is passing through these two slits at individual slit, because width of the slit is of the order of lambda, so first diffraction is taking place. So this term, first term, this is representing the diffraction. Diffraction at individual slits. At individual slits. Diffraction at individual slits. First is this. And this, what is this cos square beta? From where this is coming? This is coming out from the interference experiment. So this cos square beta, it is representing interference. 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 So what I was saying here, I was writing here that first light is passing through the slits, it get diffracted. So you are getting diffracted light. Then after that, interference takes place between diffracted light. So in this experiment, first diffraction is taking place, and after that, in between diffracted light, interference is taking place. So here in this way, you find out this point P. Okay? In this way, you can choose. So you have to consider all the wave that is emerging from here. So try to understand here, you are going to consider all complete part of this. Okay? So one part is this. Suppose another part you choose here. Okay? So similarly, you will have another part moving at the same angle. It will get focused at some other point. You are going to get this point here. You will get an intensity here. This part which is traveling parallel to the original direction, that is going to be focused here at this point. So parallel part, that is going to focus here in this way. So basically here what you are doing, you are choosing parallel part. So here this is the parallel part that I'm considering here. This is the parallel that is focusing here. So from both the slits, ठीक है ना, light is emerging and you are choosing parallel part of light. So first you choose this blue light, ठीक है ना, that is blue color lines which I have denoted by blue color. They are focusing here. You choose another angle theta, so you will get intensity at this point. If you consider this part, you are going to get this. If you choose some another angle here, if I choose some another angle here like this, then this light is going to focus somewhere here. So you are choosing all the parts of the light which is emerging, and what you are doing very simple calculation. You are considering parallel part, and with the help of this lens, okay, I am focusing these parallel parts of the light in the focal plane. And as a result, whatever interference pattern you are going to get at infinity, you will get that diffraction pattern, okay, diffraction plus interference pattern here on this screen. So in this way, you are going to get double slit diffraction pattern here on this screen. So in this experiment, first diffraction is taking place, and after diffraction, ठीक है ना, try to understand if light is getting diffracted from a slit, whose width is of the order of whose width is of the order of lambda, then try to understand at every point on this semicircle, okay, at every point intensity will be different, theta dependent intensity. You can choose any of the direction, intensity will be A sine alpha. Amplitude will be A sine alpha upon alpha, and this alpha is theta dependent. So if you are changing theta, then intensity is going to change. So what you are doing, you are choosing parallel part of the light that are traveling, and you get the pattern here on the screen. Is this clear what I am saying? Is this clear to everyone? What is happening here in this experiment?
Yes, sir.
Okay. So what is the intensity at this point? I find out this one. This one. This is the formula of the intensity here. This is IP. Remember this formula. This will be. Now, what type of pattern you are going to get? So here, I'm going to tell you what type of pattern you are going to get. Okay, before that, I will show you something else. So try to tell me one thing. If you are having only single slit, okay, if you are having only single slit, then due to the single slit, what type of intensity pattern after diffraction you are going to get? That pattern will be something like this. This type of single slit diffraction pattern you are going to get. If only one slit is there, first slit is there, you will get this intensity pattern on the screen. If you are having only second slit, you will get this pattern. So individually these slits, they are producing this single slit diffraction pattern for intensity. Okay, here this will be alpha, and here this will be the intensity. Now suppose you are having point slit, suppose diffraction is not occurring. Only interference is taking place. ठीक है, only interference is taking place here. I have removed interference. Only diffraction is there. Now in second picture, I'm just saying that only interference is taking place. So for this, we are going to reduce the width of it and make it to point slits. So what is going to happen? Diffraction will go, only interference will occur. In that case, what type of pattern you are going to get? You will get interference pattern where you are going to get this type of maximas and minimas of equal height in every direction. You are going to get this type of interference pattern. Height of all the maximas will be equal. They will be of equal width. Spacing will be equal. They may look like here that their width is different, but they are having equal width as well as equal spacing. Beta is same. Okay. So here to here separation, that is beta. Here to here separation, that is beta. So this type of interference pattern you are going to get. Okay. Now suppose, okay, suppose now both are taking place. Try to understand why you are getting same maxima, same height maximas here. Why you are getting these maximas of the same height? Can anyone answer me why in interference you are getting in every direction at all possible thetas you are getting this? In all possible thetas, what was the intensity? Intensity that was 4a square sine square delta by 2. ठीक है? And what was delta? Delta was equal to pi by Yeah, or I can write it as 2 pi by lambda, and that was E sine theta. This was the phase difference. At every theta, whatever will be the direction of theta, in YDSC experiment, you are getting the same intensity. Why? You are changing theta, but maxima is not going to change. This maxima is obtained at theta equal to 0. It will be a different theta. It will be a different theta. It will be a different theta. So all these maximas, you are achieving these maximas at different theta. But still, their heights of all the maximas are equal. Heights of all the maximas are equal. Why? Why it is like this? That their heights are equal. The reason is very simple here. Here you are having a point slits. You are having, and if you draw this semi circle here, okay, then at every point amplitude of the light will be same, because this is a point slit. So a wavefront will emerge, and on this wavefront at every point amplitude is going to be same, because this is a point slit. So whatever wavefront is going to emerge here at every point, this is A, this is A, this is A, this is A, A. So in every direction, the light that is traveling, its amplitude is A. From the second slit also it is happening. So from here, if you choose the second slit here, point slit, so whatever light is emerging in every direction, its intensity is A. So you can choose any of the arbitrary direction here. You choose this direction, suppose theta. Then you know that amplitude is A here, amplitude is A. You choose another direction, amplitude is A, amplitude is A. You choose another direction, amplitude is A, amplitude is A. A. So you can choose any of the set, any of the parallel moving set of lights. Okay, what will be the I maxima? I maxima will be simply A plus A whole square. Because A1 and A2 for every set, that is equal to A, that is same throughout at every angle. So in every direction, whenever condition of maxima is satisfied, intensity will be same. So that's why all these maximas are of the same height. This is the reason why you are getting the maximas of the same height. But now, in this experiment, what is happening at individual slit, diffraction is taking place. And when light is getting diffracted, automatically in every direction, amplitude of the light, propagating light is different. Okay? Here, what is going to happen here? You are having first slit, you are having second slit here. And whatever light you choose, any of the arbitrary in this direction, light intensity will be, amplitude will be A1, A1. But if you choose another direction here, another set of parallelly moving light, this was A1, A1. Here, it will be A2. This will be A2. If you choose this direction, it will be A3. This will be A3. So in every direction, amplitude of the light is different due to diffraction. Amplitude of the light is different. And if you choose the angle corresponding to this minima or this minima on both sides, basically intensity of the light corresponding to the angle this one and this one, or this minima or this minima, these minimas are corresponding to some directions, and in this direction intensity of the light that is propagating is 0. It means no light is propagating in that direction. So this will be plus theta 1, this will be plus theta 2. I call it as theta 1, and this as theta minus theta 1. I call it as plus theta 2. I call it as minus theta 2. So try to understand, after diffraction, okay, there will be some direction. This will be plus theta 1, suppose. This is plus theta 1. This is theta 1. Then you know that intensity here is 0. What is the meaning of intensity 0? After diffraction, suppose this is theta 2. Intensity is 0 here. Intensity is 0 here at theta 2. What is the meaning of intensity 0? means no light is propagating in this direction. When intensity is 0 in these directions, then it means you are saying no light is traveling in this direction. So after diffraction, in every direction, at every different theta, intensity of the propagating light is different. And even you are having, not only this, even you are having some directions corresponding to diffraction minimas in which no light is traveling. Intensity of the light is becoming 0, it means no light is traveling. Why intensity was becoming 0? Because when light was superposing in these direction, that was a destructive interference. ठीक है? Light superposed destructively and intensity becomes 0 in these directions. So even after diffraction, even you are going to find out direction in which no light is traveling. So try to understand when amplitude of the light traveling in different directions are different. So when they are going to form maximas in different directions, then after interference, whenever they are going to find the maxima, they are going to match the condition of maxima. Intensity of this maximum intensity will be different. Height of the interference maximas will be different in different direction, because different intensity light are propagating in different directions. So after double slit diffraction experiment, when interference is going to happen between these two parts of the light which are emerging from slits 1 and 2, basically in different direction, whatever interference maximas are found, they will have different heights. And who is going to decide the height? The intensity of the light that is propagating in that direction. And who is deciding how much intensity is propagating in different direction? This pattern. This pattern is going to tell me the intensity of the light propagating in different directions. So what I am going to do, ठीक है, I will plot this here. So I'm plotting this pattern here. So what is going to happen? Here, try to understand, in this direction, intensity of the light is greater after diffraction. So automatically here height of the interference maxima will be, height of the interference maxima will be large. But try to understand, in this direction, intensity of the propagating light is different. So their heights will be modified due to diffraction. So due to diffraction, basically you are going to get modified heights of these interference maximas. So this type of pattern you are going to get here. I'm going to tell you. So here its height will be modified to this. Height of this is modified to this. So height will be modified corresponding to the intensities of the light available in this direction. So here it will be like this. They are going to modify like this. ठीक है ना? So it will be. So this type of pattern you are going to get. So this is 1, 2, 3, 1, 2, 3 here. This will be 4 here. This will be 5 here. And there was a missing here. 1, 2, 3. Fourth will be here. Fifth will be here. And another will be here. This type of pattern will be here. After this, you are going to have this type of pattern. So after double slit diffraction, this envelope is governed by the diffraction taking place at individual lights. But position of these interference maximas, which are called as principal maximas, which are known as principal interference maximas or simply interference maximas. Their position is governed by the interference that is taking place. So here, what I am saying, so here in this pattern, this envelope ठीक है, is governed by diffraction ठीक है, and position is governed by interference Who is representing the diffraction? Diffraction is represented by sine square alpha upon alpha square. ठीक है? This term is representing diffraction at individual slits. So who is going to decide this envelope, this alpha? And what is alpha? Alpha is pi by lambda. Pi by lambda, this is E sine theta. So try to understand this envelope is actually governed by the width of the slit. So this is the width of the slit E that is deciding this envelope. This envelope is going to shrink or it will expand as you are going to change this E. As you will change the width of E of the slit, then automatically this envelope is going to be enlarged or it will shrink. Okay? It will shrink. So how many interference maximas will lie inside this envelope? Okay, na? That is decided by this E also. Now second part, position of interference maximas. Here please write is interference maximas. Position of interference maximas is governed by the interference itself. Okay? So which term is representing interference? Cos square beta. In intensity, this term is representing interference. And what is beta? Beta is, if you look at, this is pi by lambda, and this is E plus D sine theta. So who is deciding the position of these interference maximas? Basically this E plus D, separation between two slits. This is deciding the separation between these maximas. What will be the separation between two principal maximas? That will be beta, you are aware. And beta कितना होता है? Beta, you are aware, that will be capital D lambda upon small d. So this is corresponding to beta of YDSC experiment. So this is beta. In YDSC experiment, if you remember, what was beta? Beta was capital D lambda upon small d, or small d was separation between two slits. So here it will be E plus D. This will be beta here. And capital D will be equal to the focal length. So you can write it as F lambda upon E plus D. F lambda upon E plus D. This will be beta. So this is separation between. Why? In Young's double slit experiment, it was D lambda upon small d, not E. E was missing in YDSC. Why? Because you were using point slits and width of the slit was negligible as compared to D. So that's why in YDSC experiment, this was simply capital D lambda upon small d. But here, because slit width is of the order of lambda, That's why here this is the separation between two slits E plus D. Here you are considering the width of the slit also. Okay? You are considering the width of the slit also. That's the reason. So this type of pattern you are going to get. So what is actually double slit diffraction? What is double slit diffraction pattern? Actually, this pattern is made up of interference maximas of varying height. And these varying heights, it is creating an envelope that is diffraction envelope. Diffraction that is taking place at individual slits. But actual pattern is these interference maxima, that is the actual pattern. So diffraction pattern is made up of interference maximas of varying height, changing height. Okay, so this type of pattern you are going to get. Now next question is, what will be the position of this diffraction minima? You are just going to tell me what will be the position of diffraction minima, this minima, sorry, this diffraction minima, this minima, this minima, this minima. So what will be the position of diffraction minima? That will be same. Who is going to decide? Diffraction minima, position of diffraction minimas. Diffraction minimas. What it will be, that is very similar to the single slit diffraction experiment. So basically envelope is decided by at individual level at single slits. So by single slit diffraction, this envelope is decided. So condition of minimas and maximas, diffraction minimas and diffraction maximas will remain same as they were in single slit diffraction experiment. So for minima, it was E sin theta. And you can say this is plus minus. I'm writing it as m lambda. And m will be how much? M will be equal to, sorry, m will be 1, 2, 3 like this. Okay? What will be diffraction maximus? So that was E sin theta. First it may be 0, 3 lambda by 2, 5 lambda by 2. This will be, okay, 7 lambda by 2. So it will be like this. Okay? Is this okay, beta? Okay? So these were, you can go to the single slit experiment and you can check you are getting these values. Okay? You are getting these values for so diffraction maximas and minimas, they are corresponding to diffraction which is taking place at individual slits. Now next, position of interference maximus. So for this, it should be plus minus n lambda. And what was the part difference? That was E plus D sin theta. And that is equal to plus minus n lambda. And here, n will be 0, 1, 2, 3 like this. Okay, this will be the condition. So these are the conditions of interference maximas, diffraction minimas, diffraction maximas. Okay? Is this clear to everyone?
Yes, sir. Yes, sir.
So interference maxima minima, they are They are similar to YDSC. In YDSC, this E was 0. So it was, in that case, this was d sine theta equal to plus minus lambda. Here it is becoming E plus d in place of d. And diffraction maxima or minima, they are very similar to single slit diffraction experiment. Single slit diffraction experiment. So this is another aspect. Next, there is one more thing here that is called as absent order or missing order. One more important phenomena is there, and you will find out many times they have asked questions based on this double slit diffraction experiment, and you need this condition, which is called as absent order or missing order. So next is missing order or the absent order. Missing order or absent order. What is the meaning of absent order or missing order? Missing order means missing interference maximum. Missing order means missing interference maximum. So some of the interference maximas are missing. Why they are missing? Okay. So some of the interference maximas are missing. Okay, they are missing. But question is why? Why they are missing? Why these some of the interference maximas are missing? Look here. Come to this. Look here. Try to understand. This is the direction in which no light is propagating. Okay? So this is the direction in which no light is propagating. Here, intensity of the light is 0. Here, intensity of the light is 0. No light is propagating. This is suppose minus theta 1. This is plus theta 1. Okay? This will be plus theta 2. This will be minus theta 2. So these are the direction in which no light is propagating. So if in these direction, in the direction theta 1 or theta 2, some interference maxima is falling. Okay? Suppose here you are having diffraction pattern. In diffraction pattern, you are getting interference maximas of equal height. So there are interference, so many interference maximas are there. Their height is equal. But after diffraction, when diffraction is also introduced through the slit width, okay, then what is happening? There are some particular direction in which no light is propagating, because in those direction diffraction minima is occurring. Suppose in the directions in which diffraction minima is occurring, some interference maxima is appearing. Okay, some interference maxima is also appearing in that direction. So that will be missing. So if when there was no diffraction and suppose interference maxima was here at theta 1 and theta 2. Now you introduced diffraction by increasing the width of the slit to the order of lambda. Then what will happen now in this direction? Theta 1, no light is propagating. So whatever interference maxima was appearing at theta 1 and theta 2, that will be missing. That is going to be missing. So in very simple word, suppose there is no diffraction, only YDSC experiment is there. And I am assuming at theta 1 and theta 2 direction plus minus theta 1 and plus minus theta 2, you are getting interference maxima. Now you increase the width. And suppose at theta 1 and theta 2 minima, diffraction minima is occurring. It means no light is now propagating in theta 1 and theta 2 direction. So whatever maxima was there, whatever interference maxima was existing in these direction, that will be absent. When there is no light to interfere, there will be no interference. When light is not available for superposition or overlapping. So in that particular direction, no overlapping, no superposition, no light is there, no interference will take place. That will be the case. So what I'm saying here, it means if some of the maximas, sum of interference maximas, sum of interference maximas, interference maximas coincides with diffraction minimas, with diffraction minimas, then they will be absent. Then they will be absent from the diffraction pattern, from double slit diffraction pattern. Diffraction pattern and are called missing orders. Are called missing orders. They are called as missing order. So what is the condition of interference maxima? This will be E plus D sine theta n. This will be n lambda. I'm not writing plus minus. On both sides it will be. So this is the condition of interference maximum. Interference maximum. Suppose this nth principal maxima coincides with diffraction minima sin theta. ठीक है, angle will be same. ठीक है, so that's why I'm removing this. So this is some particular direction theta in which nth interference maxima is occurring, and suppose in the same direction you are getting diffraction minima. Diffraction minima. They are falling in the same direction. Minima. Then this maxima will be absent. Then try to understand this interference maxima will be absent if they are falling in the same direction. Divide these two conditions. ठीक है, divide these two. So on dividing these two, what you are going to get, because theta is same, sin theta will cancel out. E plus D, separation between two slits is equal to n upon m. And this is the condition of missing order. ठीक है ना, this is the condition of missing order. Condition of missing order. Missing order. ठीक है, so if I place m equal to 1, m equal to 1 means first order diffraction minima. First order diffraction minima. Diffraction minima. That then this n. Then this n will be E plus D by E. This will give me the missing order. This will give me the missing order. ठीक है, suppose E is equal to 0.2 millimeter. just I'm simply taking millimeter, and D is 0.4 millimeter. Then this is 0.2 plus 0.4 divided by 0.2. So this will be 6 by 2, this will be 3. It means nth order plus minus 3 order, plus minus 3 order, interference maximas will be absent. So this is the order of missing order. N equal to plus minus 3 will be absent. If you consider second order diffraction minima, suppose at the position of second order diffraction minima, some interference maxima is falling, then automatically that will also be absent. So if you place m equal to 2, means you are saying second order diffraction minima. In the direction of second order diffraction minima, whatever interference maxima will fall, that will be absent. So here if you write m equal to 2 here, then this n will be 2 times E plus D by 2. So this will be 2 into 3, suppose. So this will be 6 plus minus 6. So this is another missing order. Missing order. So what will be if you write n equal to 3? So missing orders will be plus minus 3, plus minus 6, plus minus 9. They will be the missing order. They will be the missing order. So what is the meaning of missing order? If these are the missing order, try to understand if the plus minus 3, plus minus 6, plus minus 9, they are the missing order. Then how many interference maximas? How many interference maximas? Interference maximas will lie in the central envelope. If this is the missing order, if these are the missing order, then how many interference maximas will exist inside the central envelope? So try to understand, you are having this type of diffraction envelope you are having. So this type of interference envelope you are having. This is, okay, this is 0 here. So here third is missing. Third is going to fall here. This was plus 3 order of principal maximus. This was the minus 3. They are missing. N equal to plus minus 3, they are missing. So how many will be inside? So try to understand, inside n equal to 0 will be available. This will be n equal to 0 maxima. N equal to 0. Then there will be n equal to 1 order will be there. Then there will be n equal to 2. And then this will be missing. So n equal to 1 will be there. N equal to 2 will be there. And here n equal to 3 is missing. This is missing. Similarly here, this will be 1, this will be 2, and 3 is here. So this is n equal to minus 1. This is n equal to minus 2. And this is minus 3. N equal to minus 3. So they are missing. So how many are present inside the envelope? If third order is missing, 2 on this side, 2 on this side. So 2 plus 2 plus 1, 5. So here, 5 interference maximas. 5 interference maximus will lie inside the central envelope. will inside. Now, another example is if missing orders are like this, if missing order, suppose I'm saying missing order are ±5, ±10, ±15, they are the missing order. Then how many interference maximas will be there? 4 + 4, 8. ठीक है, fifth will be missing. So up to +4, up to -4. So 4 + 4, 8 + 1, 9. So 9 interference maximas will be there. Maximas, ठीक है, will be inside the central envelope. So this was another aspect that is necessary. For today, I am going to stop here. In the next class, I will discuss all the questions related to single slit and double slit, whatever is needed in your exam. Okay, I will discuss 10, 12 or 15 questions, roughly 12 or 14, 12, 15 questions. And if you can solve those questions, you can solve all the questions of single slit and double slit diffraction pattern. Okay, beta. So please look at these slides. You can save them. This is the first one. This is the first one. This is second. This is third. Fourth. Fifth. Sixth. And seventh. Last one. So in the next class, I will discuss questions, but I suggest you to write all the formulas of single slit and double slit at the same page. Only few formulas are there. In single slit, two formulas are there. For minima, it will be E sin theta equal to plus minus m lambda. For maximas, for diffraction maximas, it will be E sin theta equal to 0 plus minus 3 lambda by 2 plus minus 5 lambda by 2, like this. Intensity in case of single slit diffraction is A square sin square alpha upon alpha square. Alpha is pi by lambda E sin theta. So these formulas you should remember for single slit questions. For double slit, you are having one or two more formulas. For intensity, I equal to 4a square sin square alpha upon alpha square cos square beta. So in case of alpha, this is pi by lambda e sin theta. In case of beta, when interference is taking place, it is pi by lambda, but this time it is e plus d sin theta. For the missing order, condition is e plus d by e equal to n by m. This is the condition you are going to use. And for interference maxima's condition is very simple, E plus D sin theta equal to plus minus n lambda. So please write all these equations at the same page and then you can solve any of the question. I will explain you how to solve these questions and you will not need anything else. Okay? So you can solve all the questions of these two topics. Okay, beta. Thank you very much.
Thank you, sir.
Welcome, beta.